Hello and welcome everyone to our weekly session titled Latest in Bitcoin Tech, where we go through the Bitcoin Optech newsletter. And this week we'll be going through newsletter number 347. And for the new joinees, um, this is a session where weekly we discuss the Optech newsletter, which is a newsletter that contains the latest evolutions from the world of Bitcoin tech. We cover some news articles, some questions and answers, some releases and release candidates. We discuss them, notable code and documentation changes. Sometimes we go over Bitcoin Core PRs. Sometimes we go over consensus change proposals, so on and so forth. This week, what we have is the news section. As every week, we cover one of it at least and then see whether time permits us to take more of them. So we'll start with this one discussion of testnets 3 and 4 because I believe this will interest the listeners more than the other news articles. I will read through the news article and then we will try and discuss it further. If at any point in time anybody feels like asking a question, sharing something, or speaking, please feel free to unmute yourself. I won't pause and ask you to do so. Just feel free to unmute yourself and interrupt me, or you can post in the chat. I'll try and keep an eye on the chat every once in a while. So the news article being discussion of testnets 3 and 4. Let's just read through the news article first. Source Provost posted to the Bitcoin Dev mailing list to ask whether anyone was still using testnet 3 now that testnet 4 has been available for about 6 months. The newsletter 315. So those of you who have been closely following the news around testnet know that testnet 4 was released, I believe, either coinciding with or slightly before Bitcoin Core version 28.0. And currently, there are two active testnets, testnet 3 and testnet 4. So, testnet 4 has been available for approximately 6 months. Andres Shilbach replied with an intention to continue using testnet 3 in the testnet version of his popular wallet for at least a year. Ololuwa Osentoken noted that testnet 3 has recently been much more stable than testnet 4, illustrated his point by including screenshots of the block trees for both testnets taken from the fork.observer website. Below, find our screenshot showing the state of testnet 4 at the time of writing. So this discussion is surrounding testnet 3 and 4. All right. One developer and Andres Schildbach replied with an intention to continue using testnet 3, right? So basically, there was a post made to Bitcoin Dev mailing list inquiring about whether people are using testnet 3 or testnet 4. Is there a reason to continue maintaining testnet 3, so on and so forth? And the replies have been consolidated. One of them stating that their intention to continue using testnet 3 for at least a year for the tested version of their popular Bitcoin wallet. Another person, Olaoluwa Osentoken, if I'm not mistaken, he is the co-author of Mastering the Lightning Network, along with Andres Antonopoulos. He noted that testnet 3 has recently been much more stable than testnet 4. He illustrated his point by including screenshots of the block trees for both testnets taken from the fork.observer website. Below, find our screenshots showing the state of testnet 4 at the time of working. So another person replied to this post stating that as per their observation, testnet 3 is more stable than testnet 4. By stable, I believe that the block producing time is more stagnant and stable as compared to testnet 4. After Austin Token's post, Antoine Ponceau started a separate thread to focus on the testnet 4 issues. He argues that the testnet 4 problems are a consequence of the difficulty reset rule. This rule, which only applies to testnet, allows the block to be valid with minimum difficulty if its header time is 20 minutes later than its parent block. Provost goes into more detail about the problem. Ponceau proposes a testnet fork, a hard fork to remove the rule. Mark O'Hart suggests a date for the fork, 2026-0108. So Anton Ponceau started a separate thread to focus on the testnet 4 issues, right? He argues that the testnet 4 problems are a consequence of the difficulty reset rule, all right? So the screenshot indicates that the block production time of testnet 3 is more stable than testnet 4. Now, there's a reason for that. What's the reason for that? The reason for that is the difficulty reset rule, right? So if you have been following how testnet 4 differs from testnet 3. One of the new attributes introduced to testnet 4 is the 20 minutes difficulty rule. What is the 20-minute difficulty rule? If no block is mined on testnet 4 for 20 minutes, the difficulty of the network goes down to minimum difficulty, which means you can instantly mine a block. So if no block has been mined on testnet 4 for 20 minutes, and then you show up to mine a block using your CPU, the difficulty will be the minimum possible network difficulty, meaning you will be able to mine a block instantly. Why is that? That is to ensure that development work is not halted due to increase in hash rate of testnet 4. We have, I believe most people might be knowing that as the name suggests, testnet 4, which indicates that there have been three preceding testnets. And there is a reason why those testnets, one after the other, were abandoned. 1 and 2 completely abandoned, and 3 is still active, might be deprecated and abandoned in the near future. The reason being, slowly and gradually, as more and more people start diverting their hash rates towards these testnets, the competition, the block production competition, becomes more and more fierce. So what happens is that when more and more people start mining on these testnets, the competition becomes fierce and the block production time reduces. And some people even start attributing value to these testnet coins. Primarily, testnet coins are supposed to be intended to be used only for development and testing purpose. They are not supposed to be used as a store of value or a medium of exchange. However, historically, it's been observed that people start using advanced devices like GPUs or ASICs to mine on testnet. What that does is that it creates competition between miners on the testnet, due to which developers who are using obviously their CPUs, they're not professional miners. Most of them might not even be having professional mining equipments, cannot compete with these miners. So if somebody is using an ASIC to mine on the testnet, a developer who's using a CPU to mine on the testnet cannot compete with them. And if, as a developer, you cannot mine your own block, then it obviously hinders your purpose of developing on the testnet. So to ensure that this does not happen again, a 20-minute rule was introduced such that if no block is found on the testnet for a period of 20 minutes due to fierce competition, due to high hash rate, then what happens is that the difficulty instantly reduces to the minimum network difficulty, and a block will be found instantly with the CPU, so that the development process is not halted. Now what this might do is that this might lead to people abusing this rule. How will that happen? A person can very easily manipulate the timestamp in the block header. They can put a timestamp 20 minutes into the future and then mine a block instantly, and they can keep on doing that repeatedly for at least, I would say, 6 blocks, right? Because we know that a block that is more than 2 hours ahead in the future is considered as an invalid block. So somebody can manipulate the timestamp of their Bitcoin blocks header 20 minutes into the future, thereby leveraging this rule and instantly mining a Bitcoin block. And then they can further manipulate it and push it 20 minutes into the future. They can further manipulate it and push it 20 minutes into the future. They can do it at least 5 times. After which, if they try to do it for the sixth time, then the timestamp in the block header will be 2 hours in the future, and thus the block will be deemed as invalid. So at least 5 times somebody can leverage this rule and manipulate the timestamps and the block headers to mine blocks instantly, thereby leading to what is usually referred to as a block storm, which is the reason why there's instability or there's drastic variance in the magnitude of block production on testnet 4, because people are exploiting this rule. People are putting timestamps 20 minutes in the future to instantly mine a block, and they can do that for 5 subsequent blocks. So 5 blocks can be produced within no span of time. Within, like, instantly, 5 blocks can be produced by manipulating the timestamps, leveraging this 20-minute rule. And that is why there have been proposals made or suggestions made to do a fork and get rid of this rule. As is mentioned, I'll just read this passage again before we read the actual mail and the Bitcoin dev mailing list. After Austin Token's post, Anton Ponsa started a separate thread to focus on testnet 4 issues. He argues that the testnet 4 problems are a consequence of the difficulty reset rule. This rule, which only applies to testnet, allows a block to be valid with minimum difficulty if its header time is 20 minutes later than its parent block. Provost goes into more detail about the problem. Ponsop proposes a testnet for a hard fork to remove the rule. Mark Ohart suggests a date for the fork, 2026-0108. Wow, that's like what, over a year from now. Right. Let us read the mail. I'm not sure if this leads us to the mail. Yes, it does. Okay, we'll read it. It's not very big. Okay. So dear Liz, testnet 4 was proposed last year in BIP 94 and is supported by Bitcoin Core version since version 28. To make Bitcoin Core easier to maintain, we would like to drop support for testnet 3 in a future release, right? Because maintaining support for two test nets simultaneously obviously increases the overheads of the developers, right? If you are a developer that's maintaining a software that is expected to be compatible with two different versions of test nets and both having different set of rules, it adds overheads. So to keep things simple and to reduce redundant burden from the developers, the proposal is to slowly and gradually do away with testnet 3. So future releases of a Bitcoin Core don't exactly know what those future releases would be, might not be compatible with testnet 3. This will happen no earlier than version 30 this fall. The upcoming version 29 release still supports it, right? So 28 supports it, 29 supports it, 30 might not support it. And will throughout its maintenance period. Okay, now even if 30 doesn't support it, I believe the usual period for the maintenance of a Bitcoin Core version is 2 years. So if version 29 is launched, then for the next 2 years, it will be supported, which means that the testnet 3 will remain active for slightly over 2 years. The network itself can't be deleted, so anyone willing to maintain node software themselves can keep using testnet 3 until the end of time, right? So the network will not be abolished, as in the network cannot be deleted in and of itself if somebody else is maintaining their own client using an older version of Bitcoin Core, for instance, using a fork of Bitcoin Core or a standalone implementation of Bitcoin, which is compatible with testnet 3, then they can continue working with testnet 3. As for Bitcoin Core's version 30 onwards, they might not support, they might not extend their support for testnet 3. One of the motivations for introducing testnet 4 was that testnet 3 became increasingly impractical to use due to block storms. These are what block storms are. What are block storms? When a large number of blocks are mined rapidly in a very small span of time, then that is referred to as a block storm. And that was happening with testnet 3 as well, right? Because a lot of people were using advanced devices to mine on testnet 3, which led to block storms. And there was also this time warp attack, which people were exploiting to manipulate the timestamps in the block headers and thereby produce blocks, lots and lots of blocks at a very tiny time interval. So perhaps everyone already moved on to using testnet 4 or a signet. As an aside, it's possible to create a pure proof of work permissionless signet without any signatures by setting the challenge to opt true. This is interesting, right? By signet, we mean it's it's basically a parallel Bitcoin network where blocks are not mined by uh, exerting computational work. Rather, blocks are mined by issuing digital signatures, right? So for the mainnet and for the test net, you actually have to mine blocks. You have to exert computational power to mine blocks. As for the reg test, then it's a local network. It's a local network. You don't have to exert actual computational power because it's a local adiabatic environment within your computer. As far as the signet is concerned, as the name suggests, you need to furnish digital signatures. The person who possesses private keys uh, is authorized to issue digital signatures, whereby blocks are mined at intervals when digital signatures are issued. Right now, as we understand that this is centralized because the person who holds the private keys to the digital signature is the one who's authorized to publishing blocks. That doesn't happen on the mainnet and the testnet because no one person or no one entity is authorized to issue blocks. Unlike Signet, where one person or a group of people that possess private keys to the corresponding digital signature of the signet are authorized to produce uh, blocks. However, there is also like a variation of signet where your your script sig will get unlocked, meaning it'll pay to an opt-through opcode, right? It'll pay to an opt-through opcode, meaning anybody can mine a block. Anybody can mine a block. It's not confined to any central authority or a group of people. Opt-through means anybody can mine a block, right? The script will evaluate it true by default. However, if anyone is still using testnet 3 and needs more time to move away from it, please let us know. Example as a reply to the list or a comment on the GitHub issue. This could include libraries, staging environments, testnet wallets, etc. Although the version 29 maintenance window will last for a few years, it's also important to know if dropping testnet 3 would prevent you from upgrading to the next major node version. In other words, if migrating away from testnet 3 would take you longer than all of 2025. Although I don't feel like it isn't a great technical argument, it's still useful to know what to expect and perhaps others can help, right? So basically, this was a Bitcoin dev mailing list post by, I might not be able to pronounce the entire name, Schwarz Provost, right? Inquiring developers whether they are currently using testnet 3, whether they are actively using testnet 3, whether they are using any wallets, building any wallets, they are using any libraries that are dependent on testnet 3, and what is their opinion about slowly and gradually doing away with testnet 3. And we saw what the replies were. Some people said that they are using testnet 3 actively and might continue using it for the foreseeable future. Some people said that testnet 3 even today is more stable as far as the block production time is concerned as compared to testnet 4. Some people suggested that the issues pertaining the variance in the block production time of testnet 4 is owing to its 20-minute difficulty rule, which people are manipulating to create block storms. And then there was a proposal made or a separate thread that was started to tackle this situation, which led to people suggesting that a hard fork needs to be executed on testnet 4 to get rid of this 20-minute rule. And a date was also suggested to get rid of this 20-minute rule, that being 2026-01-08. And as the mail suggests, that Bitcoin Core's version 28 supports testnet 3, 29 will also support testnet 3. However, 30 onwards, it is not expected to support testnet 3. However, the network in itself cannot be deleted, and that is why any libraries or standalone implementations of Bitcoin or forks of Bitcoin Core that are reliant or still compatible with testnet 3 will continue to extend their support to testnet 3. However, Bitcoin Core version 30 onwards won't be. And as the Bitcoin Core extends its maintenance support to all of its versions, I believe for around 2 years. So even after version 29 is released for a good 2 years, that being, I believe, mid 2027, Bitcoin Core will continue extending its support to maintaining testnet 3 and maybe not after that. So that is what this discussion was around testnet 3 and testnet 4. If anybody was not able to comprehend something, has anything to share, anything to ask, anything to post, please feel free to go ahead and do so. Uh, just for the new joinees, we are going through the Bitcoin Optech newsletter. It's a newsletter that is published once every week that contains the latest evolutions in the world of Bitcoin tech, from Bitcoin to the Lightning Network to Nostr, from wallets to libraries to cryptography to Bitcoin Core to mining. It covers peer reviews. It contains the latest news articles. It contains interesting questions and answers. It contains a mention of releases and release candidates. It contains a mention of notable code and documentation changes in Bitcoin and its multiple implementations, and Lightning and its multiple implementations. And we at Bitshala do a 60-minute session where we get together and discuss this newsletter. Obviously, it's not possible for us to discuss the newsletter in its entirety due to time constraints, but we try and pick and choose the news articles or the sections of the newsletter that we believe would be interesting to the listeners. So please feel free to join us if you want to speak, unmute yourself and talk. If there's a news article or something that you'd like to talk about or discuss, please feel free to ask access of the mic and feel free to engage. We discussed the second news article from the news section, and now we will move on to the question and answer section, and we'll cover that hopefully for the next 30 minutes. If there's anything that somebody has to ask, how do I learn more about Bitcoin basics? There are various ways to do that. Uh, as far as our this session is concerned, then this we don't cover absolute basics here. You need to have an intermediate level of understanding, right? But if you're willing to, pull up your socks and uh, wrap your head around intermediate and advanced level concepts, then you're more than welcome. But if you want to begin from absolute basics, then I would suggest you to join the Mastering Bitcoin cohort. So at Bitshala, we arrange multiple cohorts, right? These cohorts are group study sessions where you are paired along with other people who are more or less at the same level of understanding of Bitcoin as you are. And you have TAs who help you and assist you, and we pick a book and we read through that book. It's a self-study cohort, so you have to prepare from yourself. Once in a week, you have to show up along with your peers, answer questions, complete assignments, and the TAs will be there to help you. We just completed one of our Mastering Bitcoin cohort, and we will announce the second Mastering Bitcoin cohort very soon, or hopefully before the end of this month. So follow Bitshala on Twitter and be active on Discord. We'll soon be announcing the next Mastering Bitcoin cohort. As an absolute beginner, the best way to get started in Bitcoin is with Mastering Bitcoin. So they just watch out for the announcement. And we'll soon be starting probably in a week or two. Me and along with me, Coding P, we'll be the TAs for the Mastering Bitcoin cohort session. That will be for absolute beginners. Other than that, if you are interested in wrapping your head again around the intermediate and advanced level concepts, then feel free to join us on Mondays, 8 to 9, where we cover the Bitcoin Optech newsletter. And if you have any other questions, feel free to post on Discord and people will be more than happy to help you. All right. We'll move over to the stack exchange questions and answers. Let's see how many of them are we able to cover in 30 minutes. So the first question is, why is the witness commitment optional? Peter Woola and Antoine Ponceau explained BIP30 duplicate transactions, BIP34 block version 2 height in Coinbase, and consensus cleanup considerations are around the block 1983702 problem and how making the witness commitment mandatory would resolve the problem. Let us read the question. Okay, so we have this forum or this platform known as Bitcoin Stack Exchange where people can ask questions, right? So this is also a good place to start learning about Bitcoin. If you want to explore a certain topic, you can go and check out questions pertaining that topic and what people have answered. Bitcoin developers have answered about it. This is a thoroughly moderated and reviewed platform. If you have any questions, you can post your questions here as well. So this is the monthly feature in the newsletter. Once every month, they handpick a few questions and they incorporate them in the Bitcoin Optech newsletter, and we'll be covering some of them, right? So the questioner asks, why is the witness commitment optional? What is the witness commitment? It is the witness program, or it is that which is known as the combination of the public key and the script sig, which was stripped off the anatomy of a Bitcoin transaction post the SegWit softbook. All right, so here is the question. Let me zoom in a little. So, as can be read in BIP 141, the witness commitment is optional. If all transactions in a block do not have witness data, the commitment is optional. We have a known issue that could lead to Coinbase transactions have the same TXID, which is the problem because it can lead to make coins impossible to spend. Those cases are not covered by BIP34, and as far as I know, BIP30 is no longer in use. See this resources for the collision cases. Seems that making the witness commitment mandatory would solve it as the TXID would change. Why was this rule not enforced since the beginning? I could understand that you don't want to force people to upgrade instantly to SegWit and cause fork on the chain. But in that case, why it is not enforced now when all miners are running SegWit so avoid a possible attack? All right. So there is a known issue pertaining the Coinbase transaction, right? Coinbase transaction is the first transaction in a Bitcoin block. It is a transaction that pays the miner. So the miners get the block subsidy in the form of the block reward and the transaction fee via the Coinbase transaction. Now, as we know that each Bitcoin transaction must have a unique TXID, now, what can happen is that there is a possibility that two Coinbase transactions might have the same TXID. Two Coinbase transactions might have the same TXID. How can that be? The beneficiary could be the same, the amount could be the same. We know that Coinbase transactions don't have inputs, right? So the output amount can be same, the beneficiary can be same, and all the other relevant fields might be same, leading to two Coinbase transactions having the same TX ID, thereby one Coinbase transaction overriding the other Coinbase transaction. And thus, the Coinbase transaction that is broadcasted first will get redeemed, and the Coinbase transaction that gets broadcasted later, the coins will not be able to be the miner will not be able to claim those coins, right? So if two Coinbase transactions have the same TX ID, one will override the other. Now to avoid this, what do? There's this BIP known as BIP 30. Okay. Now what does BIP 30 do? BIP 30 basically checks that all transactions have a unique TX ID. It checks that all transactions have a unique TX ID. Then we have a BIP called BIP 34. What does BIP 34 do? BIP 34 makes sure that all Coinbase transactions have included their block height as arbitrary data, quote unquote arbitrary data, right? So every Coinbase transaction will have to include its block height. What happens is that every Coinbase transaction obviously will have a unique block height. And when every Coinbase transaction has a unique block height, then obviously the TX ID will be unique, right? Because if the data is unique, then the hash operations function such that if the input is unique, the output will always be unique as well. So BIP 30 was implemented initially where each transaction was checked to ensure that its TX ID is not being repeated, but that was computationally pretty extensive. And thus, BIP 34 was implemented where the Coinbase transaction, every Coinbase transaction will have its block height included in it, right? Will have its block height included in it, thereby ensuring that every Coinbase transaction will have a unique TX ID. Post the implementation of BIP 34, BIP 30 check was no longer made, right? Because if you're ensuring that every Coinbase transaction has unique data, then that implies that every Coinbase transaction will have unique TX ID. Then you don't have to check for the TX ID's uniqueness because that's redundant computational work, right? So BIP 30 is no longer being used because BIP 34 ensures that every Coinbase transaction has a unique TX ID. However, it is observed that some blocks before the SegWit soft fork are used as added data heights of certain blocks, right? So let's assume there's a block number 900,000, right? So the Coinbase transaction of block number 900,000 will have the number 900,000 embedded in it to ensure that it has a unique TX ID in compliance with BIP 34. Now let's assume there's a block before SegWit, before the SegWit soft fork was activated, where the miners just randomly decided to put 9,000 as random data in the Coinbase transaction, right? And there are such cases where in the future we will have blocks that have that will have the same block height as compared as the data that was added by the miner in a Coinbase transaction preceding the SegWit soft fork, right? Now, although it is very unlikely that although the factors will also remain constant, like the block reward, including the fee, will also be the same, the recipient will be the same, everything will be the same, right? If everything is the same, then there is a possibility of the TX IDs matching and the latter Coinbase transaction overriding the previous Coinbase transaction. However, that's highly unlikely. Assuming that happens, like chances are very big. Assuming that happens, what avenue or solution or remedy do we have for that? Why can we not make SegWit mandatory? The Coinbase transaction currently can be a SegWit Coinbase transaction. It can be a pre-SegWit Coinbase transaction. If it's a SegWit Coinbase transaction, then its TX ID will always be unique. Okay, because even if its block height is the same as used in one of the Coinbase transactions preceding SegWit, because the anatomy of the transaction is different. The digital signature, the script sig, and the digital signature and the public key have been stripped off of the transaction and have been separated. That will ensure that the data that enters the hash operation is different, thereby ensuring a unique TX ID. So why can't we make SegWit mandatory in the Coinbase transaction, right? Initially, it wasn't made because 95% of the network upgraded to SegWit, but there were 5% people who had still not upgraded to SegWit, right? To ensure that this does not get repeated, break compatibility, and people who are using non-SegWit legacy nodes also continue interacting with the network. This change was not made. But the questioner says, why not now? Because now more or less the entire network is upgraded to SegWit. All the miners have upgraded to SegWit, right? So now why are we not making Coinbase like SegWit compulsion for Coinbase transactions that will ensure that the Coinbase transactions here onwards will always have unique stakes IDs, and that is why and that will solve the problem of recurring Coinbase stakes IDs, right? So let's see what the answer says. Uh, the answer, I believe, repeats the question or a passage from the question. We have a known issue that could lead to Coinbase transaction having the same TXID, which is a problem because it can lead to make coins impossible to spend. Those cases are not covered by BIP34, and as far as I know, BIP30 is no longer in use. See this resources for the collision, yes. So the answer says yes and no. The BIP30 soft fork disallowing duplicate Coinbases activated in March 2012 and has been active since. Reverting it would require a hard fork. BIP34 hide in Coinbase is also active and mostly covers the same problem. So much so, in fact, that we do not actually perform the BIP30 check anymore. As due to Bitcoin Core's database design, it involves a non-cacheable database access. And since BIP34 makes it impossible to actually violate BIP30, there is no real need to still check, right? As we discussed above. BIP34 ensures that all transactions have included their unique block height, thereby ensuring that they have a unique TXID. There's no need to perform a BIP30 check. Except there exist historical pre-BIP34 blocks with unspent Coinbase outputs, which have BIP34 like heights in their Coinbases. This is what I discussed or I referred to when I gave an arbitrary number of block number 900,000. Just following BIP34 can, in theory, 20 years from now mean a duplicate can still be created, which would be disallowed by BIP30. The concern isn't loss of coins, it would require the same miner. Like I said, the chances are very meager. It would require the same miner in the year 2045 to mine the same Coinbase transaction, which probably means using the same software stack as they did in 2012 without ever spending the 50 BTC they've held onto this full time since 2012 while collecting approximately 50 BTC in fees. Otherwise, the repeated Coinbase would not be valid in 2045 to accidentally trigger this. The concern is that someone might deliberately recreate the Coinbase in order to fork off part of the network, those that do and do not enforce BIP30. This would be expensive as it means foregoing the income for the block, but Bitcoin should be resilient against the case someone might still try this. Because of this, the current Bitcoin Core software re-enables the BIP30 enforcement in 2045. Okay, this is quite news for those who did not know. So BIP30 checks are not being made right now. However, Bitcoin Core software is configured in such a manner that BIP30 checks will be enforced in 2045, where it is possible, even though the chances are very meager. However, it's possible that we might have a Coinbase transaction ID that is the same as one of the pre-BIP34 Coinbase IDs, and that's why BIP30 check becomes mandatory because BIP34 will not be able to detect that, and that is why Bitcoin Core code is configured in a manner that BIP30 is enforced again in 2045, which will mean a slight performance degradation because obviously BIP30 means you have to check all the TXIDs, which is more computation expensive, as I just mentioned previously. If the software still exists in its current form, then it's not a very big deal, but it just feels necessary. If another consensus rule can categorically remove the BIP30 concern, this check could be avoided then, however, right? So the answer to this says there's no reason to make SegWit transactions mandatory as Coinbase. Why? Because in 2045, 20 years from now, if the same miner using the same software stack mines the Bitcoin block that pays the same Coinbase reward to the same address, only then there is a chance of the former Coinbase transaction overriding the previous Coinbase transaction, and the chances of that happening is absolutely negligible. And even if hypothetically, for the sake of argument, we believe that it happens, then Bitcoin Core's code base is architectured in a manner that BIP30 is enforced again in 2045 to check for identical TXIDs. And if that does happen, and a Coinbase transaction in 2045 has a TXID which replicates the TXID of a preceding Coinbase transaction, then that transaction will be considered null and void, meaning that transaction will be considered invalid and it will not make the previous coins redundant, or it will not lead to the loss of previous coins, right? That is more or less what the answer is. There's another answer as well. Anybody who's more interested in reading that can do that on their own. We'll move on. I believe we covered as much as we had to, right? So that's the reason why uh, SegWit transactions are not compulsory to create a Coinbase transaction because we have a solution for this replication of Coinbase transactions in 2045. All right. Anybody has anything to say? Hey, Faisal, this is not related to this week's activity. Wanted to know if we have F2F engagement. If yes, any idea when we can plan an indoor? I will be happy to help. I believe that by F2F, you mean face to face. Um, Face-to-face engagements do keep on happening. I am not sure when will be the next one. We recently had a summit, a 4-5 day long summit in Goa, where lots of folks from Bitshala were present. And we usually have activities in Bangalore. For indoor, you can probably post on Bitsala's Discord server. We have a very active member of Bitshala who is based in Indore. You can catch up with him. There are get-togethers that happen in Indore as well. So maybe you can get in touch with Shriyan. He'll be able to help you. You can DM Shriyan or maybe just post in any of the relevant chat groups on Bitshala Discord server and just tag Shriyan. He'll help you, right? So Shriyan is your man for Indore. And other than that, we have monthly get-togethers in Bangalore. If you're in Bangalore, then you find monthly get-togethers. Stay tuned on Discord or follow Bitshala on Twitter. But for Indore, Shriyan would be a person. He frequently visits Indore, so maybe you can get in touch with him. Okay, all right. Let's move on to the next one. The next question is, can all consensus valid 64-byte transactions be malleated to change their size? We directly open it. The questioner says, can all consensus valid 64-byte transactions be malleated to change their size? All right, the great consensus, this is the question, all right? Looks like the answer, but it's the question. The great consensus cleanup proposes to make 64-byte transactions consensus invalid for various reasons. They have been non-standard for years and appear to serve no useful purpose, right? So if you follow Bitcoin tech closely, then I'm sure you've come across this term called great consensus cleanup, right? This is a proposed soft fork that is an amalgamation of multiple bug fixes and vulnerability fixes. It proposes to make 64-byte transactions consensus invalid. Currently, 64-byte transactions are consensus valid, but they are non-standard. Okay. So in Bitcoin, we have this thing called policy rule and we have this thing called consensus rule. Whatever does not comply with consensus is invalid outright. The nodes will immediately reject it. It will not even be propagated to the network. However, if there is something that is consensus valid but policy invalid, then the nodes that comply with that policy will propagate it. It'll be considered as a non-standard transaction, meaning most of the nodes that adhere to the default policies of the clients that they're running will not propagate that transaction. However, nodes with modified policies might propagate that transaction, right? So consensus invalid is outright rejected. Policy invalid, if it's consensus valid, then it might not propagate as rapidly across the network, but it will get propagated via nodes that comply to that specific policy. It appears that any such transaction can be malleated into a different size so that in practice, I'd be happy if somebody could at least post in chat what is the minimum standard size of a Bitcoin transaction. Like, feel free to unmute, interrupt me and answer, or post in the chat. Okay. What is the minimum size of a standard Bitcoin transaction? And when I say standard, I'm referring to Bitcoin Core. All right. 64 is non-standard as we've just read. So what's the minimum size for a standard transaction? Let's see if anybody can answer that. It appears that any such transaction can be malleated into a different size so that in practice there is no confiscation risk, even if such a transaction were useful. I'm trying to understand this aspect better. Given a UTXO-A, which either already exists or is freshly mined under the current consensus rules, example, through a non-standard transaction, given a 64-byte transaction T that spends it non-standard by definition, without access to the secrets, if any, that were used generate T, private key, hash, pre-image, etc. Is it always possible to change T into a consensus valid transaction T that spends A? Additionally, if I understand correctly, it's not possible for any 64-byte transaction T to send coins to a destination B that is a secure public key hash. Regardless, for every B, is there a malleated T dash that preserves B, at least still spendable by the private key B? If the latter is too hard to prove, and one one could show that any T can be malleated by an attacker to divert coins away from B. So basically, the questioner asks that, uh, you know, what would be the consequences, or basically, primarily the question is, can 64-byte transactions be malleated unconditionally, right? Is it possible to malleate any and every 64-byte transaction, yes or no? Okay. The answer is, in brief, no. In brief, no. Not every 64, and we'll see how. Not every 64-byte transaction can be malleated by a third party, which means that there are certain 64-byte transactions that can be malleated by a third party. If a transaction spends a SegWit output, example P to WPKH, the input can have a signature in the witness and it won't count towards the 64-byte target, preventing third parties from changing the output script or attaching more inputs, right? So when we say what's the size of a standard Bitcoin transaction, we don't include the SegWit witness in that, right? You don't include the witness in that. Excluding the witness, what is the size of a Bitcoin transaction? So when we say that that the standard size of a Bitcoin transaction should minimum be X bytes, we exclude the witness program, all right? So if we exclude the witness program, and let's say we have a PWPK transaction, okay? Let's say its size is 64 bytes, okay? And let's say that uh, it has a witness program. The witness program obviously has a digital signature, which means you cannot malleate that transaction, because if you malleate that transaction, its TX ID will change. If its TX ID will change, its digital signature will not stand true. So not all 64-byte transactions can be malleated. If a 64-byte transaction is a SegWit transaction, you cannot malleate that transaction, because making any changes to that transaction will lead to a different TX ID, which would invalidate its digital signature, because the digital signature commits to the transaction, including its TX ID. The TX ID is changed, the digital signature will not stand true, right? So first thing we learned is that not all 64-byte transactions can be malleated. Some 64-byte transactions can be malleated. Which ones cannot be malleated? One example is a SegWit transaction. If there's a SegWit transaction which is 64 bytes in size, excluding its witness program, it cannot be malleated, because the witness program commits to the TX ID, and changing any non-witness data will lead to a unique TX ID, thereby invalidating its digital signature. However, per Shaw's answer, such a transaction can only have a 4-byte output script, which is necessarily spendable either by everyone or no one. How can a 64-byte transaction be malleated, right? So this is basically the minimum size of a Bitcoin transaction. It's 60 bytes. Okay, 4 bytes for version, 1 byte for input, 36 byte for previous output, then 1 byte for this, 4. If you do the math, it turns out to be 60 bytes, right? Okay, it turns out to be a 60-byte transaction. So the minimum size of a valid Bitcoin transaction is 60 bytes, provided its script sig is empty. It has an empty script sig and it has an empty script pub key. Okay, the script sig is empty and the script pub is also empty, right? Now, what you can do is, if the script sig is empty and the script pub key is empty, you can make changes to that transaction such that it pays to an opt2 script, right? Because anybody can redeem an opt2 script. You don't need a digital signature to redeem an opt2 script. Anybody can redeem an opt2 script, because it always evaluate to true, right? So if there is a 64-byte transaction where the script sig is empty and the script pub key is empty, you can either add an opt-return to its script pub key, or you can add an opt-true to its script sig. If you add an opt-true to its script sig, it will evaluate to true. And then anybody can claim coins, right? So if you have a Bitcoin transaction that's 64 bytes, it has coins associated with it. It has an empty script sig, it has an empty script pub key, it's 64 bytes or less. Then you can add an opt-true to its script sig. So the script will always evaluate to true, and you can redeem those coins. Or you can add an opt-return to the script pub key and then burn those coins, right? So the questioner asks, is it possible to malleate every 64-byte transaction? transaction? The answer is no. It's possible to malleate some, it's not possible to malleate some. Which are the ones that cannot be malleated? If we see a 64 byte transaction, which is 64 bytes, excluding the witness program, then we cannot malleate that transaction. Why? Because making any change to the non-witness data will lead to a unique takes ID, thereby invalidating its digital signature. Now, which are the transactions that we can malleate? Let's assume there's a transaction that's 64 bytes or less that has an empty script set, that has an empty script pub key. We can malleate that transaction either by inserting opt2 in its script set, thereby claiming the coins associated with that transaction, or by including an opt return in the script pub key, thereby borrowing those coins and making them unspendable, right? So there are certain situations in which you can malleate a 64 byte transaction. There are certain situations in which you can not malleate a 64 byte transaction. Now the question stands: what is the minimum size for a standard Bitcoin transaction as per Bitcoin code? Let me see if anybody's answered here. I can see somebody has answered. I guess 130, your guess is wrong. Even I'm guessing, okay? I did not look this up. I believe it's 82. I'm as sure as I can. I think I read it somewhere. It's 82. Okay, so maybe you can cross check later. Maybe I can cross check later. But my guess is 82 bytes. Let's see later on. All right. Let's take one more question. Which question? Cool. This will be interesting. How long does it take for a transaction to propagate through the network? The questioner, how long does it take for a transaction to propagate through the network? What is the estimated time for a transaction to propagate throughout the entire network after being broadcast? A node does not have a full view of the entire network, only its peers, right? A Bitcoin node does not have the view of the entire network. It is only aware of its own peers, right? It knows its peers, it recognizes its peers. It does not know all the hundreds and thousands of nodes that are present in the network. Itself cannot retrieve that information as to how long does it take for a transaction to propagate across the entire network, because the node does not have the view of the entire network. It has only the view of a subset of the network. A node can estimate how long it takes for its own transaction to reach its peers, but how can a node determine if its transaction has propagated through the entire network and reached miners? Can we estimate this and determine an average time based on the current network conditions, or has this been previously estimated? The answer is yes. This isn't something a node can do on its own. To compute an estimate of the propagation time, multiple active monitoring nodes running modified or custom software need to be deployed to track how long it takes for a transaction sent from a given source to reach all of them, right? So the answer is yes, it's not possible for one single node running a default Bitcoin software client to determine how long does it take a given transaction X to propagate across the entire network. It's not possible for it to do that because one single node doesn't have the view of the entire network. It has a view only of the subset of the network. And if you want to find how much time it takes for one transaction to get propagated across the entire network, then you will have to use a custom software that is configured to do that task. And you will probably then be able to trace the trajectory of a specific Bitcoin transaction and see how far it traverses within a given span of time. And I believe there is a link as well. I think there's a website that does that. So if anybody is eager to trigger the node within them, then they can go and have a look. According to the most recent data, a transaction takes about approximately 7 seconds to reach 50% of the network, right? So that's pretty rapid. That's pretty rapid. So if you create a transaction and you broadcast it, it takes approximately 7 seconds for it to reach 50% of the network. And I believe there are around 80 to 90,000 full Bitcoin nodes on the network right now. So it takes merely 7 seconds for your transaction to reach uh, more than half of the network, and about approximately 17 seconds to reach 90%. Notice that this doesn't mean it will take that long to reach minus, right? So this is the amount of time that it takes on an average, as per the research conducted, for a Bitcoin transaction to reach 90% of the nodes. However, this does not mean that it takes 17 seconds for it to reach the miners, right? It'll reach the miners before that. Usually, reach the miners before that. But miners are likely to be better connected than regular nodes, so I'd expect them to receive most transactions closer to the 7-second mark. So it's expected that most of the miners will receive the transaction within 7 seconds, right? So as per the research conducted and a source that's been quoted, it takes approximately 7 seconds under normal circumstances for a Bitcoin transaction after being broadcasted to reach 50% of the nodes on the network, and it takes approximately 17 seconds to reach about 90% of the nodes in the network, and it takes approximately 7 seconds to reach a miner that can include that transaction in a Bitcoin block. Right, we still have some time. Uh, which one? Let's take this one. This is quite interesting one. And would take a lot of time. I think we can take another one. Yeah, we can take two. Both of them should not take a lot of time. Why are there no BIPs in the 200 range? This is something even I got to know right now. That there are BIPs like you find BIP 10, BIP 30, BIP 34, so on and so forth, BIP 141. You'll find BIP 353, you'll find BIP 431. But you'll not find any BIPs in the range of 200. So the questioner asks, why are there no BIPs in the range of 200? The Bitcoin BIPs repository seems to skip the range of 200 to 299 entirely. Why is that? One of the BIP editors, maintainers, Luke Dasher, has kept them reserved for Lightning BIPs as he thinks long term the bolts and future Lightning proposals should be incorporated into the BIP process. So right now we know that Lightning proposals are incorporated as BLIPs, BLIPs. So these numbers have been reserved so that in the future there could be a possible integration such that we have BIPs that will include Bitcoin as well as Lightning proposals. And that is why this range of 200 to 299 has been reserved. Quite an interesting fact. Let's do this one. Why doesn't a Batch32 use the character B in the data part? So the question asks, Batch32 is basically a standard encoding format that is used for Bitcoin transactions. I believe these are used for SegWit transactions. The data part of Batch32 address uses alphanumeric characters excluding 1, B, I, and O. I understand that 1 and I and O are excluded as they could be mistaken for other similar looking characters, and another character needs to be removed to get down to a base 32 character set. But why B, right? So some characters are removed from base 32 that resemble each other. That might lead to typos or human errors, such that 1 and I they resemble each other, and that's why they remove. And O and 0, so they removed O, and the basically resembling characters are done away with. And then after removing the resembling characters, we came down to 33, so we had to get rid of one more to come down to base 32. So why did they choose B? Why did they choose B instead of using any other character? Out of all the remaining characters that could be removed, it seems like I, that is lowercase L. Oh, sorry, this is L. Lowercase L might have been the next choice, right? So if we had to remove one more, why not remove this? Because this looks similar to small I. This looks similar to capital I. This looks similar to one. Why did we not remove lowercase L? Why did we remove B? Is there any specific reason why B was excluded instead? So the answer is says B was removed due to similarities with 8. This comes from RFC 4648. So B when written might resemble 8. This 8. That is why they got rid of B. You don't need to remove I lowercase L since number one is already removed, right? So the lowercase L resembles 1, but since we've already removed 1, we don't have to remove I because it does not resemble any other character that is compatible with the Batch32 encoding format. So when we had to reduce one more number, they got rid of B because it resembles 8. Fun note, the order of the character set was thought up in order to maximize 1-bit errors when people make common errors like Z for 2 or S for 5, most similar characters. Okay, I did not find it that fun. Uh, there's one more thing that I read when I was reading this answer. Let me see if that's possible. Yeah, this is interesting. Okay, from what I understand, it is to avoid similarity of strings, possibly not only when read. This is why they ban 0, for instance, so it does not get confused. O, for instance, so that it does not get confused with 0. But also when said, pronunciation of B might get confused with that of V or P, or spelling could be confused with B, right? So one reason that was given by the answer is that B, when written, resembles A. Another very interesting answer given is that B, when pronounced, resembles V or P. So if you are narrating if you're dictating your address to someone and you say B, they might get confused with V or P. So that is why this was removed. So when B is written, small case, lowercase B is written, it resembles 8. When it's pronounced, it resembles V or P. So that could be a reason why B was done away with in the best 32 encoding format. We're at 9:05, exactly 1 hour since we commenced. And that is all we have to share with you folks for this week. Thank you so much for joining us.